get it started. So today let's take a look at composite figures. So really we're looking at the area of composite figures, not so much the perimeter. We did that a little bit yesterday. So we're looking at the area of composite figures. And you had a little introduction to this yesterday on your notes and on your homework, but we're really going to delve into it today. So really the goal of today is that you can find the area of composite figures. So when I'm talking about a composite figure, I'm really talking about they're figures that are made up of two or more geometric figures. So it could be trapezoids, it could be squares, it could be circles, it could be rectangles, it could be parallelograms, it could be anything. Now for our lessons, it's really going to be the three that we focused on. Parallelograms, which include rectangles and squares and rhombuses, and then also trapezoids and triangles. So we're really going to only look at these three main areas. And there are really two types of composite figures. Okay? Type 1 is an additive figure. Okay, and that's not a specific name, but it just gives us an idea where we take a space and we add on an extra figure. So I've got two real rectangles here. Or I've got a subtractive, okay, where either I have an overlapping area or I have a cutout, something like that, or even something along this line where there's an overlap between the two. Well, a little more overlap like that between the two. So you could see that they'd have to take something out. So it just depends on how you really put it together. That's a really bad version of that, but you get the idea of an additive or subtractive figure. So we're going to start with the easier of the two, and that's the additive figures, where you just have to add the different areas of two different geometric figures together, and then we're going to look at the end, and we're going to look at the ones that subtract. Okay, so let's take a look at our first figure. So really what we're looking at is we need to cut this figure up into those two or more geometric figures. Now you can cut this up many, many different ways, but probably the simplest is to cut it into two shapes, a rectangle and a parallelogram, because we don't know technically those are 90-degree angles, and a triangle. So with this, what we really want to do is get used to saying, okay, this is figure A, this is figure B. So I've got these two, and together they're additive area because I'm going to add the area of figure A plus the area of figure B to get my answer. So first thing I'm going to do is I'm going to find the area of figure B, and that's a rectangle, so I'm going to use base times height. And then the second B is a triangle, so I'm going to use 1/2 of base times height as my two formulas. And now I'm going to fill in my base and height. So the base of our first rectangle is 10, so 10, and our height is 6. Now it's a little harder to find the next one, so plus 1/2. So our base here, now we know this from here to here is 6, but we don't have it specifically stated what that distance is, so we have to do a little bit of subtracting. We know that down here is 10, and they're parallel to each other because it's a parallelogram, and more specifically, it's a rectangle. So we say, okay, if these are parallel, they're also equal distance. So if this is 6 plus what equals 10, so we know that the base of this is 4. And we already have the height marked at 4. So now we're just going to do the math with our order of operations. 10 times 6 is 60. Half of 4 is 2. 2 times 4 is 8. And then we finish up the problem by saying it's 68 and then inches squared. That's my answer for this problem. All right, go ahead and take a look at the second problem and pause the video and see what you can come up with. So again, this has a figure A and a figure B. We'll say A is our rectangle, B is our triangle again. So we have very similar problems. We have base times height plus 1/2 of base times height. Same basic figure structure. Now here, I've got a base of 10 and a height of 15. So that's a pretty easy one to find the rectangle. Now half, and this time I have the base. I've got the 5 for the base. But the height's a little bit harder to find. So again, we look up here, we got this picture, this is 14. From here to here is 10, so what's the additional section? If that's 10, 10 plus what is this? So that must be 4, so my height is 4. So again, follow order operations, 150 plus half of 4. Now I'm gonna use my little bit of a commutative property here, so a half of 4 is 2, 2 times 5 is 10. So I've got 150 plus 10 is 160, and again, this time it's centimeters squared. All right. Now, what if we use different shapes? This time, instead of having a triangle and a rectangle, I have a rectangle and a rectangle or a parallelogram, either same formula, and a trapezoid. So I'm still having figure A and figure B, and I'm going to cut it right here. So we'll call this A, call this B. So the figure A is 1/2 of base 1 plus base 2 times height. And remember, bases are always the ones that are parallel to each other. So 1/2 of 4 plus 6 times the height of 2. All right, and then we're going to add in our base times height. So our base on this case is 28, and our height is 14. So I'm going to use a calculator because I don't really want to do all this math in my head. And it'll be much faster if I just clear it to do that times in myself. So I found that 28 times 14 is 392. And 4 plus 6 is 10. 1/2 of 10 is 5. 5 times 2 is 10, so we've got another 10. So we have 402, this time, feet squared. That's how much of the floor, if we ever had to replace this floor, change the color, do whatever we wanted, it would take 402 feet squared of material, square feet of material. All right, your turn to figure this one out. Pause the video and see what you come up with. All right, so again, we have these trapezoids. Now, one of the neat things about this is there are two of the exact same trapezoids. They're both 5 height, 18 for one base, 10 for the other. So I'm going to, instead of doing these two separate formulas as a figure A, B, and C, I'm going to call these both figure A and figure B. So I have 2 times figure A plus figure B. Well, so 2 times 1/2 base 1, which is 10, which is 18, plus 10 times 5. Excuse me. Need an extra parenthesis there to finish up. Plus 20 times 18. Sorry, 20 times 18. There we go. So let's just do our math. 10 plus 8 is 28. So that's 1/2 of that is 14. 14 times 5 is 70. And then, 2 times 70, it's 140. Plus 2 times 18 is 360. So that shows us out that we have 500 square feet. That's a huge window. That's a very, very large window. All right. All right, so this is our first subtractive figure, because if you think about drawing a piece of paper and kind of an idea about this piece of paper, if I had 2 pieces of paper and I overlap them, there'd be 2 layers. I only want to know what the area with 1 layer down. So I either have to cut it out, or I can take and figure out the area of this middle figure, figure C, and we're going to call it this, and we'll talk about this. So we really are still going to find the area of figure B plus the area of figure B, A and B. B includes this area. A also includes this area. So we're going to call this area C. So really what I've got to do is, since it's listed twice in there, it's part of figure A and part of figure B, I'm going to subtract out the area of figure C to take out one of those 2 areas. So I'm really going figure A plus figure B minus figure C. So they're all rectangles, or all parallelograms, so I'm going to use base times height for each one of them. The base and height are 12 on figure A, so 12 times 12. The base and height on figure B are 12 and 15. And now I've got to figure out figure C. So I know that from here to here is 8, and I know the whole thing is 15, so I know this measure is 7. From here to here is 12, and this part's 6, so this has to be 6. So minus 7 times 6. So again, I'm just going to type all this into my calculator and go, okay, this is 144 plus 180 minus 42. And then I use my calculator, 144 plus 180 minus 42. And you can type all that as one step. Your calculator will get the problem correctly. And it goes, okay, the answer is 282 centimeters squared. Okay, it's your turn to try one of the subtractive area problems. Go ahead and take a look at this figure and figure out what the area of this shape is. Now you pause this figure. Let's work it out. It's the same figure A plus figure B minus C. So we're going to call this A, B, and C is the overlap section. So A is 5 times 2. B is 2 times 3. C is, okay, so if this is 1 and this whole thing is 2, so that's also 1. This is 1 and the whole thing there is 2, it's also 1. So I've got a 1 by 1 minus 1 times 1. So 10 plus 6 minus 1, I get 15 meters squared. That's still a pretty good size space. Okay. All right. One more practice problem, more real life in this case. So we're going to figure out, so this in college and high school, sorry, not high school. In college, a lot of times you share a common area with other people. So sometimes you might have your own space, and then you have a common area that you share, maybe a kitchen or a bathroom, or a kitchen or a living space or something like that, but you each have your own room, maybe your own bathroom. So it's pretty common that's normal here. Here's an idea of how that works. So Charlie and his brother Matthew are neighbors in an apartment complex. They will share a patio. So they both have access to that same patio. What is the area of both shapes? Of both the apartments and the area of the patio. So the nice thing is both Matthew and Charlie's apartment are exactly the same size. So I don't have to do two separate problems. So we're going to call the apartments figure A. They're both the same. And we're going to call this figure B. So what the nice thing about this is, since they're both the same, I can figure out just the area of figure A and figure A at the same time. So we know figure A is a rectangle or a parallelogram. We're going to know it's 45 times 55. That's the base and the width. And now we're going to, this time, instead of adding together two figures, we're going to subtract out the patio. So the patio is figure B. Now I got to figure out what figure B is. So we know if this is 22 and this is 45, that makes this space 23. If this is 32 and 55, 55 minus 32 is again 23. So a 23, and I'm going to say it's 23 squared because that's a shortcut to that. So we're going to come in and go 45 times 55. That gives me 2,475. And then we're going to subtract out the patio. 23 squared is 529 square feet. So I already know the area of the patio. The patio is 529 square feet. Okay, now to find the area of this, so I'm going to take 2475 and subtract 529. And that tells me the area of the apartment is 1,946 square feet. So, and that's the same for both Matthew and Charlie. They both have the same size apartment. So here's my apartment and my patio space. All right, it's your turn. A shopping mall is formed by two connecting hallways. What is the area of the hallways shown? Now, this is a massive space. Think a shopping mall. We're talking massive amounts of space. So pause the video and see if you come up with this answer. All right, this is more similar to the last couple problems we've been working on. We have a figure A, a figure B, and a figure C. And together we'll add up figure A and B and subtract figure C. So figure A is 250 squared. Figure B is 150 times 300. And then figure C, we got to figure out our math here. So we know from here to here is 150. If that's 60, that means this is 90. From here to here is 250. If this is 60 of it, this is 190. So 90 times 190. So 250 squared is 62,500. 150 times 300 is 45,000 square feet. And then 90 times 190 is 17,100 square feet. So I'm just going to type all that in my calculator. 62,500 plus 45,000 minus 17,100. That gives me a total square footage of this mall is 90,400 feet squared. So now you've got a really good idea of how all these work. If you have questions, please reach out and ask me. I'm happy to help you. I'll see you tomorrow.